So for this lesson, we will be reviewing those transformation rules and applying them to quadratic functions. So in this video, we will also be talking about how to write functions based on the transformation. So a quadratic function is a function that can be written in the form f of x equals a times x minus h squared plus k, or a does not equal 0. So this is vertex form, which we introduced in the last lesson. And so it does create that U-shaped graph called a parabola. So here is that parent graph of x squared. And then the blue graph over here is a transformation. So this one actually has some shift. And it has been shifted 1, 2, 3, 4 units to the left and 1 unit down. And so we have ways that we can use that with our transformations. And we already talked about transformations once in unit 1, but of course, this is going to come back up with every function that we talk about. So just to kind of make things a little bit easier, and for every single type of transformation, it always has a certain spot that it lands when it comes to the quadratic function. So A is that vertical stretch and compression. It's always right in the front. And so if A is greater than 1, it stretches the function like a rubber band. And if it is less than 1, it causes what we call vertical compression or shrink. And of course, if it is less than 0, it flips the graph upside down and reflects it over the x-axis. So this is a reflection, a transformation all of its own. This is the reflection that you will see most of the time with quadratics, because it's really hard to see a reflection over the y-axis with these functions unless it happens at the right time, because this function is symmetrical, so it's really hard to see those. And then the B is a horizontal stretch and shrink, so that is why it's in the grouping symbol. In fact, that may be easier just to put there, because it's horizontal. And remember that anything horizontal is backwards land, so that's why any value greater than 1 actually compresses the function, and then any value less than 1 stretches the function. Now, if your B is less than 0, then it is going to be reflected over the y-axis, but this is the one that you will not see often. Now, C is horizontal shift. So if it is less than 0, so if you have subtraction, it is going to shift to the right. And then if C is greater than 0 or it is positive, then you need to shift to the left. So D is always at the back of the function, and it is going to shift up if it is greater than 0. And if it is less than 0 or it is negative, then it will shift you down. So these are the same rules that we've done before. We're just applying it, of course, to those quadratics. So now we are going to describe the transformations of some functions based on the parent function of f of x equals x squared. So we have g of x equals x plus 4 squared minus 1. So this plus 4 is going to shift you to the left 4 units. And then you are going to shift up one, or shift up, shift down 1 unit with the -1. So then for B, we only have that -3, but that is going to shift to the right because it's negative. So we're going to shift to the right 3 units. And then on C, we have 2 transformations. So we have the +5 in parentheses. That is going to shift left 5 units. And then the +1 is going to shift up 1 unit. Now D has a couple of different things going on because we have that number in front and we have the negative. So that negative causes a reflection over the x-axis. So this causes that opening down that we talked about in our properties in the last lesson. Then the 1/2, that is vertical shrink by a factor of 1/2. Now for E, I have a g of x equals 2x in parentheses squared plus 1. So my 2, that is going to be horizontal shrink. And remember, we need to express anything horizontal with the reciprocal. So this is going to be horizontal shrink by a factor of 1/2. And then the +1 on the outside is going to shift up 1 unit. So then on F, we have the g of x equals 1/3 x squared. This is inside of parentheses. So this is the only transformation we have in this function. But that is going to be horizontal stretch since it is less than 1. And that is by a factor of 3 because we have to use that reciprocal. Okay, so on G, we have g of x equals 3 times x minus 1 squared. And so the 3 that is on the outside, that is going to be vertical stretch by a factor of 3. And then the -1, that is going to shift down 1 unit. Actually, not shift down, it's in parentheses. What am I thinking? It is going to shift right 1 unit because it's inside those parentheses. All right, and then for H, we have that negative on the outside. So that is going to be a reflection. Over the x-axis. And then the +3, that is on the inside of the parentheses, and so you will shift to the left 3 units, and then the +2, that will shift us up 2 units. Okay, so that's everything for example 1. So in example 2, we're going to be writing quadratic functions based on the transformations. So we're going to go backwards from what we just looked at. So we're going to let G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. So this is what we're coming from, which is our parent function. So this is where we're starting. And it does say let the graph of G. So when we write our next step, it will be the G of x because we will start transforming it. So we'll start with the G of x. And then I'll start with my x squared and just leave a little bit of space at first. So we need first the vertical stretch by a factor of 2. Now remember, that goes in the very front of the function if we think about what we did for a, b, c, and d. So it needs to be in the a spot because it is vertical stretch. So we're going to put that right in front of the x squared and a reflection in the x-axis. So that's going to be that negative that's in front. Then it's followed by a translation 3 units down. And that is going to be the +3. Now in this case, there's nothing that we need to simplify. So this is going to be our final answer. So the G of x equals negative 2x squared plus 3. So on B, it's going to say, let the graph of G be a horizontal shrink by a factor of 1/3 and a reflection in the y-axis, followed by a translation 2 units up of the graph of f of x equals x squared. So we need to write the rule for G. So we're starting at f of x equals x squared, but we're going to be writing G of x. And so we're going to have horizontal shrink by a factor of 1/3. So we need to actually write some parentheses. And then we need to use the reciprocal. And so we are going to make that a 3. So, and it has a reflection in the y-axis. So that reflection in the y-axis is a negative inside. And then we're going to be followed by a translation 2 units up. So that is going to be at the very end of the function. So we're going to have a +2 right there. And that is going to give us our final answer for this function. Now, C is going to be a little bit stickier because we are not going from the parent function. And sometimes this happens. Sometimes you don't start out with the parent function. So these last couple of examples are going to look like that. So we're going to let G be a translation 3 units to the right and 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x. So let's go ahead and take care of that translation 3 units right first. So we're starting out with f of x, actually I'm going to bring it over here, f of x equals x squared minus 5x. So this needs to be added, or actually subtracted from x. So what's going to happen is we are going to have x minus 3 squared minus 5 times x minus 3. And so that's where we're going to be, because I have to put that on both instances of x. And then we are going to be going 2 units up. So we have a plus 2. So then after that, we are going to, let's see, have a reflection in the y-axis. So what we're going to have to do is we are going to have to take that negative and we're going to have to put it in front of everything inside the parentheses. So we've got a negative 5 and then minus x minus 3 and plus 2. So after this, we're going to simplify as much as we can, because this was a problem given to us in standard form, and then we need to try to get as close to standard form as we can. So we're going to go ahead and distribute that negative. So we have negative x plus 3 squared minus 5, and then of course we have negative x plus 3 again here, plus 2, and then we are going to go ahead and FOIL what we can. So we'll have, let's see, a positive x squared, because remember we've got to do negative x plus 3 times negative x plus 3. And so it's going to be a x squared and then minus 3x minus 3x plus 9. And then we can distribute our negative 5. That's going to give us a plus 5x minus 15 plus 2. And then from here, we need to just simplify as much as we can. So we'll have x squared, and then negative 3 and negative 3 give us negative 6, and then plus 5x, that gives us a negative x. And then we have, let's see, 9 and negative 15, that gives us negative 6, and then plus 2, that gives us a negative 4. And so that is actually our final answer for the function. So now let's go ahead and let the graph of G be a translation 4 units to the left and 1 unit down, followed by a reflection in the y-axis of the graph of f of x equals 2x squared plus x. So again, we are not starting from the parent function. So we have the translation going 4 units to the left. So we're going to add 4 to both of these x's. So we have 2 and then x plus 4 squared plus x plus 4. And then we're going to go 1 unit down. So that's going to get tacked on to the end. So minus 1. And then it's followed by a reflection in the y-axis again. So we're going to have 2 times negative x plus 4 squared plus negative x plus 4, and then minus 1. So we have 2 times negative x minus 4 squared, and then plus negative x minus 4 minus 1. And we are going to have to FOIL again. So it's going to be 2, and then we've got negative x minus 4, negative x minus 4, plus negative x minus 4 minus 1. So we're going to go ahead and start foiling. So we have, I'm going to go ahead and leave the 2 for now. And then we will have the x squared. And then plus 4x plus 4x plus 16. And then we have a negative x minus 4 minus 1. So we just need to distribute that 2. So it's going to be 2x squared plus, well, we'll go ahead and do 16x. And then plus 32 minus x minus 5. Just simplify a little bit as we go. So then we're just going to continue to combine like terms. So we have g of x equals 2x squared plus 15x plus 27. And so that is where we will actually leave the function. All right, so now we're going to look at how to write the function from a graph. So this is where you're going to have to look at the graph and find the transformations. So one easy way to do that is to look at the vertex and compare it to the vertex of the parent function. And then any movement to the left or right will be horizontal shift, and so then you need to place it appropriately. Any movement up or down will be a vertical shift. And then if the graph is upside down, you have a reflection in the x-axis. And then look at how the points go out from side to side to tell you if you have vertical stretch or compression. So think about it like slope and look for where you hit an even point again. That will give you a lot of clues. And so then you need to place all of these numbers in the appropriate place for the transformation. So let's go ahead and look at a few examples here. So we need to write the function for the transformation shown in the graph. So we're going to look at where our vertex is, and we're going to find that lowest point. So in this case, our vertex is -3, -2. So this means that we have a shift left 3 units, and then a shift down 2 units. And then we are going up 1 and 1, and then we'll go up 3 over 1. This is normal movement for a quadratic function. So this does not have any vertical stretch or shrink. So we are just dealing with shift up and down or shift side to side and shift down. So we are going to put this in our parent function. So we'll have f of x. Actually, we'll change that to g of x since we transformed. And so we're putting all of these on the parent function. So we don't have any vertical stretch or shrink. And so then we're going to the left 3 units. So that's going to be x plus 3, and it's going to be squared. Then we're going to shift down 2 units. So we're going to subtract 2 at the very end. And so this is our function. So then for B, we're going to look at our vertex first. And our vertex is -4, 3. So we have gone to the left 4 units and then up 3 units. And then if we look at our movement, we also are opening down. So we are reflected. And then we went, let's see, we are going down 2 over 1. And then we are going, let's see, 1, 2, 3, 4, 5, 6, and over 1. And so if you look at what we had before, we were going up 1 over 1. And so now we're going down 2 over 1, and then we were going up 3 over 1. This is twice as big. So we have vertical stretch of 2. So we're going to put this all in our function. So we're going to have g of x equals, and we're going to put that 2 out in front. And then for that shift left, we're going to have x plus 4 squared and then plus 3. And then we need to deal with the negative since we're opening down. So we're going to put that negative out in front. All right, and then for that last example here, we are opening down, so we are reflected. And then our vertex is at -2 and -3. So that means that we have shifted left 2 units. I did not realize I did 3 examples in a row shifting left. And then we're going down 3 units. So then, looking at where we hit crosshairs again, you can almost kind of see it a little bit better if we hit the half points. But we are going up 1 over 2 and then up 3 over 2. So this shows vertical stretch, or actually vertical shrink. By 1/2. And so most of the time you'll be able to multiply those by something where you can see like that common, like we're moving in a certain way, and especially compare it to that parent function. It helps so much to compare it to the parent function. So we're going to have, let's see, g of x equals, then we're going to have 1/2, actually a negative 1/2 because we have the reflection. And then we're going to have x plus 2 squared minus 3.